Good day everyone. Digital manufacturing is the need of the hour in manufacturing sector. I am Karthik from Sri Ramakrishna Engineering College. Today we are going to discuss on the fundamentals of digital manufacturing. The subject code is 20 ME 1223 digital manufacturing. So this is the syllabus for this particular course. The first module is about CAD/CAM, which involves concepts on product design and the machineries used for manufacturing these products. We will also be discussing about CAD/CAM integration in the first module. The second module is the computer integrated manufacturing, where the earlier concepts like CAD/CAM, their integration principles, the introduction to group technology, how this group technology is used in manufacturing sectors are highlighted. The third module is the integrated approach for manufacturing, where we will be discussing the concepts of digital manufacturing in detail about their operation mode, organizational mode, functional mode, informational mode, and so on. The fourth module will be covering the Internet of Things, which is the latest trend in industries, where the connection between machineries to enable highly productive manufacturing environment is being discussed. So these are the topics that will be discussed in this particular course. So coming to the first module, these are the contents. Today we will be discussing in specific the product design with CAD. So in general, what is a product? A product is an object or a system or a service that are made available for the consumer's use for their demand. This is important. So based on the demand from the consumer and based on the requirement from the consumer, an engineer should be capable of assessing this demand and the requirements of the consumer and develop a product. And this product has to undergo a process called manufacturing to get a good viable product. What is manufacture? Here you can see a image, that is a lot of wooden logs placed, and these logs are being processed, and this process ends up with a finished good. Manufacturing is nothing but conversion of this raw material to finished goods through designated manufacturing process. So coming to the design process, all the products that are available in the market has to be designed by few people, and it has to be made available for the consumer for their usage. Here we can find two images. The first image, the design process, clearly depicts the conventional design process that are being used in industries. Actually, these concepts were used earlier, but nowadays people prefer to use CAD based applications for the simplified usage of this design process. We will discuss about the conventional design process as well as the CAD integrated design process. Say for example, in the earlier slides we might have discussed that the wooden logs are being converted to sitting chairs. Here the chair is the final product. If you could see this, a manufacturing sector has to first recognize the need of the consumer first. Say for example, if the requirement is a chair for a consumer, first it has to be identified well that the requirement of chair for what segment of market we are going to address, that has to be identified. Then we have to understand the customer's need first. For what application? The chair can be used in classrooms. These different chairs can be used in IT sectors where more ergonomic comes into picture. So the design will change, the economics play a lot. So we have to understand the recognition of need first. Then comes the problem definition. Here the problem definition is to create a suitable chair for the customer's requirement. Then we will be working on the conceptual design of the chair, like how many legs has to be there, whether there is a need for a support for the arms as well as the back. Likewise, we conceptualize. So all these conceptualizations are done in the design process. Then comes the embodiment design, where we will assign dimensions, material and all the engineering parameters that play in the working of that particular product. So after all these things are synthesized in this process, what we will do is we will get a theoretical output of the product, and this theoretical output has to be analyzed through engineering models, and it can be optimized for proper functionality. Once this analysis is done, that is, if the results are good, we move on to the next phase, which is the evaluation, or else if we find that the requirements are not up to the mark of the customer's expectation, then we go back to the synthesis stage, where we will reconsider the important parameters for the design. Again, the loop continues. Once the optimization is done, we will go for the evaluation, where the design review and evaluation are done. Once the evaluation is okay, then we move on to the presentation, where we create the 2D drawings that are useful for production. So this is the conventional model. Next we are going to discuss about the model of design process, where CAD comes into picture. All the process are same as in the conventional model. Only thing is that the systems are being simplified with the usage of computer integration. Like in the synthesis step, we used to create the conceptual model, which is supported by the geometric modeling, where 3D models are being prepared. Once the synthesis is complete, we go for analysis and optimization. Here, engineering analysis is being done with CAE software packages. Once this analysis and optimization is complete, we go for evaluation. Here, the design review and evaluation is being done by the design team members. Once the design is complete, we have to create 2D drafting of the drawings. So we can very well see that the complex conventional design process is being simplified very easily using CAD integration. So this is one of the best applications for a digital manufacturing process. So in the earlier slide we discussed about the design process, but it is also important for everyone to understand the principles of manufacturing process that comes in play with the design process. Once the design documentation is complete, where the 2D drawings are created here in the design process, once the 2D drawings are released for production, it comes to the process planning department. This process planning team, what they do is, they do the production planning, they plan for the design and procurement of new tools, they order materials for the inventory, and they also plan for CNC programming and the resources. Once all these information, all these work are being completed by the process planning team, we move on to the production. The production team takes over and they produce the product, which is nothing but conversion of the raw material to finished products. Once the finished products are being available from the production department, it has to go through this quality department. These people, the quality department, what they do is they inspect these parts. They inspect for defects on the parts. They also see for dimensional requirements. So once this inspection is completed, the quality people approve the products which are good enough to be sent to the consumer, and they are packaged and the products are shipped and are sent to the warehouses. The marketing and sales department sells those products to the consumer. This process doesn't end here. Once the products reaches the consumer, the marketing department work tirelessly to get feedback of the customer about the products. Based on the feedback, the design team can implement improvement actions on the product, and the next version of the product will be launched subsequently. So this is how the design process works inside the industries. So coming to the product design with CAD, we have to understand the concept of manufacturing support systems. Till now we have discussed about the design process in association with CAD tools. Now we are going to discuss about the manufacturing support systems. Manufacturing support systems are the procedures and systems used by a firm to manage production and resolve technical and logistical challenges. So these support systems actually helps the production or manufacturing team to manage the production and resolve the technical and logistical challenges. So the key functions are designing the product, then planning the manufacturing process, ordering and managing materials, controlling work in process throughout the plant, delivering final products to customers. So these are the key functions of manufacturing support systems. And one can very well understand that all these procedures are repetitive, and it can very well automated through systems like CAD and SIM, and it can be, and hence it is digitally managed through these software packages. So once the product design is being completed, now we have huge amount of data that must be stored and properly managed for utilization in the future. So it can be accomplished with the help of modern CAD systems through this concept called product data management. So what is a product data management? Product data management system consists of a software that provides links between the users and a central database. So this link helps the users to access the data whenever necessary, to look for geometrical models and product structures and even some bill of materials. All these data can be created automatically with subsequent related records. So once this product has been successfully designed and manufactured, this product will be launched for usage for the consumer's end. And now there is another concept which manages the life cycle of the product at the consumer's end from a manufacturer's perspective. So product life cycle management is the concept which manages the product's life since its launch to its decline at the customer's end. So product life cycle management, it is very well depicted in this graph, where first the product will be launched in the market. Slowly it will gain momentum through marketing principles. The sales will grow. Here the cost per product to the customer will be a little bit higher. There will be few financial losses, and we will get a lot of feedback from the customers about the product, and obviously there will be few competitors because of the new product availability. Now the product will move on to the next stage we call the growth stage. Here the sales will be increasing, the cost of the product will go drastically down, we have a good profit rise, the number of customers will be more, and obviously when the product is doing good at the customer's end, we will have a lot of competitors coming up. Next, the product will go into a period called maturity period, where we will get the peak sales and the minimum cost of the product at the customer end. The product's profit will be so high at the maximum. We will have a very good market availability, and we will have a good number of competitors with us playing with the same product category. After a certain period, it can be very well observed that the sale of the product comes down with time, and now the product will enter the phase called decline phase. The product here in the decline phase, the product sales will come down, the product cost is also low, the profit will come down, the customer availability will come down, and the number of competitors also will come down, since the product has a very low sales in real at the customer end. So this is the product life cycle management. To summarize the product life cycle management, once the product gets launched in the market, it will have a momentum to grow in sales. It reaches to the maximum at the maturity level, then the product sales come down. So these are the benefits of the PLM. It helps us to increase the design productivity. It increases available geometrical forms in the design, improved quality in the design, improved design documentation, this is very important. Creation of manufacturing database is available, and the design standardization is very much available through this PLM. So today we have discussed about the product design with CAD with digital manufacturing concepts. I hope you have a better understanding on the concepts of product design and in digital manufacturing. Thanks for your wonderful time. Have a nice day. Thank you.